Good morning. I will speak in English. I regret that my French is not up to the task. There are copies of translations of the slides. They would be followed closely but not exactly by the English words I will show. This talk is concerned with how one can put a price on or a value on environmental projects which are risky and which deal with environmental circumstances which are risky. And I would like to, in this talk, explain how economists approach this problem, what their techniques accomplish, and what the limits of those techniques are. This is a talk which is hopefully will be accessible to people who are not economists. Now, let me begin by pointing out that economists themselves and observers of economics do not always have a high opinion of what economists do. Oscar Wilde said that an economist is someone who knows the price of everything and the value of nothing. He's too kind. We don't know the value of everything. Another comment, economics is like the inflatable structures that enclose tennis courts in cold climates, composed of modest amounts of machinery and a great amount of hot air. Also, all the economists laid end to end would still not reach a conclusion. So the question then is what can economists, what's the role of economists in dealing with environmental problems? Well, there are two areas that are fairly non-controversial. Economists can often measure the cost to producers, consumers, and government associated with environmental projects. For example, the cost in reduced labor productivity of having early childhood malnutrition, or the lost profits to commercial fishermen due to an oil spill. We can also sometimes design markets or market regulating mechanisms to capture and internalize environmental effects. For example, economists have designed markets for tradable emission credits to control sulfur dioxide, a market which works quite effectively in the United States. There are suggestions of the use of carbon taxes to control release of carbon dioxide, and those do seem to work in a few cases where they have been opened. But one feature of environmental risks is that they often occur outside of markets or are not accounted for by markets. In fact, you can essentially take this as a definition of an environmental good or an environmental problem. It's a good where self-organized markets for the good break down. One of the primary reasons for this is that the production and consumption of environmental goods are not under the control of identifiable owners who make allocation decisions in response to price signals. So prices provide the wrong incentives, they lead to mechanism failure. And examples are water pollution, where the source of the ownership rights to clean water are not necessarily clear, traffic congestion, where there are direct impacts of one consumer's behavior on another, which is not captured through a market, and depletion of ocean fish stocks. There's also a problem in environmental goods that the market prices for these goods fail to aggregate and communicate consumer values, leading to information failure. That is to say, you cannot look directly at market information and discern from it what a consumer's values for products are. Therefore, environmental values are not immediate from economic market data. They require some indirect inference and analysis. Now, I'm going to talk primarily about this problem of valuing environmental benefits. And the issue here is this: when policymakers weigh environmental prospects, the risky environmental consequences of human activity, and interventions that affect the environment, These effects are usually stated in the language of economists and policymakers, namely monetary benefits. A question that non-economists sometimes ask, isn't it crass to put economic values, euro values, on outcomes like human lives or species saved? The answer is yes, it is crass. But these metrics drive environmental product choice and market design, and it's better to do consistent measurement with careful attention to indirect effects than to be haphazard and piecemeal in environmental policy making. So in this talk, I will talk about these value techniques. Now, a first example, this is, by the way, not in your translated slides, but I hope you can follow, would be that of climate intervention. The projects might be interventions to decrease the emission of carbon compounds into the atmosphere through promotion of energy conservation, non-carbon energy development, carbon taxes, or carbon credit markets. The question would be, what are the economic costs of these projects and what are their benefits? And that could be broken down into the question of how will the projects change temperature and precipitation patterns and acidification patterns. Is that, secondly, how will these changes affect human activity? And third, what values do global consumers place on these changes in human activity? There is, of course, scientific dispute about the causes of climate movements, but these questions are largely independent of the question of where climate change comes from. They are simply a question of whether a project to intervene at a global level in the climate through various devices would on their own bottom be desirable to do. Now, it's true that the historical record and the scientific evidence is relevant to determining what the value of these interventions might be or what their effect might be. Nevertheless, the value of the projects themselves is largely can be determined just from the costs and benefits of the project. Another example, there is a technique called fracking, a new technology for obtaining petroleum from locked strata. The petroleum is bound in strata, and by use of high pressure water and chemicals, these strata are fractured, freeing the petroleum. And this is a technology which is gaining rapid use in the United States and I think elsewhere. It has some potentially rather large environmental consequences, possible groundwater contamination, earth movement, earthquakes, surface activity associated with the oil production and transportation, and increased carbon emissions from the final use. So the question is, what is the value to consumers of restricting fracking in some areas? For example, Los Angeles is on a basin of, sits on the top of a basin of oil, petroleum. At this point, what remains is locked. There's quite a bit of it there. And it would be quite a major issue as to whether to engage in fracking under the city of Los Angeles. I'm not going to give you answers to either of these two examples. I think they would involve a very major economic analysis beyond what has been done to date. But I'm going to talk about some smaller problems where there has been work done. One is the impact of air pollution on consumer values of life and how you can measure that and determine the value of vehicle emission controls and other controls to reduce air pollution. Another is a very narrow example. There's a river basin in Montana in the United States that's damaged by copper mining tailings, which leach out pollutants into the river, and the question is, what is the value to consumers of restoring the river and keeping the leaching from happening? A final example is seabirds are killed by small releases from oil tankers offshore, basically cleaning out tanks. And the question is, what is the value to consumers of saving those seabirds? So the target in all these cases is the consumer's distribution of values for the direct and indirect effect of these activities or projects. And by the way, in line with the title of this conference on risk, both doing something and not doing something involve risk. And those are future risks about what the future consequences will be, and they are also risks about what the scientific basis and the measurement accuracy is from the past. Now, the basics of valuation in economics are these. Consider a change from old to new conditions. For example, restoration of a hazardous waste site. There's a site which has been damaged by past industrial activity, and the question is, what is the value to consumers of restoring or cleaning up that hazardous waste site? There are two measures that economists use. One is willingness to pay, which is the largest amount of money the consumer could pay or be taxed in the new state and still be willing to move to the new state with restoration. The second is willingness to accept, which is the smallest amount of money the consumer would have to receive in the state with the environmental damage and be willing to take the money rather than have the restoration. So that's willingness to pay and willingness to accept. A standard economic assumption is that these measures, willingness to pay or willingness to accept, can be summed over consumers and taken as a measure of the public welfare, of the public value of the projects. Now, the starting point for all this, for this whole approach, was a French bridge engineer in 1844 who should be counted among the giants of early economics. He isn't because he didn't have a PhD in economics, he was a bridge engineer. But Émile Dupuy, even before the development of formal economics as a field, set out to solve the problem of what was the value of providing a bridge which had a lower involved lower travel costs or lower tolls than what had been present before. So you had a starting point where there was some high cost of travel, and if you built the bridge, you'd end up at an ending point where there was a lower cost of travel. The demand would respond to the lower cost of travel with more trips, and he calculated that the value of that innovation would be the area, in this case labeled WTP equals WTA in red, which is the area behind the demand curve between the starting and the ending prices. So that was Émile Dupuy in 1844. And rather than go through his reasoning at the time, I'm going to give you quickly a modern restatement of what the foundation for Dupuy's analysis was. The idea is that consumers maximize utility, some kind of measure of their level of satisfaction or happiness in goods and subject to whatever environmental conditions they're put under, and that's done subject to some kind of budget constraint. And a consequence of that is that the utility they can get from a given commodity purchases in the market is the minimum of the maximum utility that they could get at some prices and specified income. And the reason for that is that optimal trade away from any fixed set of goods has to make the consumer at least as well off. If you take that condition, that minimization condition, and express it as a first order condition for minimization, you get an identity which is, again, due to a French economist, in this case, René Roy, in 1947. And that's the next to the last equation on this page. And if you turn around and reintegrate that first order condition, you get at least if the effective income on, if the marginal effect of income on utility is constant, then that integrates back to give you Dupuy's formula. So the 1844 original idea in modern dress due to René Roy and the implications of that are the foundation for what economists do in calculating values. Now, how do you apply that to an environmental problem? The situation, continue to think of the example of a hazardous waste site which has caused damage to the groundwater or other attractiveness of an area. And here we have two demand curves, one when the site is injured and the second when it's restored. And what happens is that with restoration, there's more, at any price, there's more demand, effectively because the commodity is now more attractive. And you can put this another way. If you thought of the demand for the site restored, you could translate the effect of injury into an increase in price. It's as if what would happen if the site is injured is its price, its effective price has to go up. So in this case, the injured demand curve has been shifted upward to a new price. Now, there are basically two techniques that economists use to measure the value of this kind of restoration. One is to compute the area ACDF in this figure, which is Dupuy's original measure. A second is to compute the price change from E to C, and that's a second method, and effectively the ACEF then becomes an approximation to the consumer value of restoring the hazardous waste site. So those are the two techniques, and the one that involves the price increase from E to C is called the hedonic price method, and the one that involves the calculation of the Dupuy area is called the travel cost method. I will say a little bit about each. The hedonic price method would start, for example, with the problem of groundwater contamination. You have two properties. Some are in a treatment area affected by the hazard. Others are in an unaffected control area. Suppose that these areas were identical in all other respects. Then what would be true is the difference in the selling prices of properties in the two areas reflects, it's not exactly, but it reflects the value consumers place on the hazard. A natural experiment is to control for confounding effects using what's called a difference in difference method and statistics, in which you have control versus treatment areas and before and during treatment. And there will be further corrections because this is a natural experiment, not a designed one. You have to control for more things, and a method called hedonic regression is used for that. Now here's the situation. Before the groundwater was a problem, before the hazard was introduced, let's say that you have two neighborhoods, neighborhood 0 and neighborhood 1, and prices in both were $100,000, or you could put that in euros as well. And then groundwater contamination is revealed to be present in neighborhood 0, and the price of houses in neighborhood 0 drops to $90,000. The conclusion would be that the mean willingness to pay in neighborhood 0 is $10,000. So multiply that by the number of affected consumers, and you have a the value of removing that contamination. I'll give an example of where this has been applied. This method has been used in a number of studies to analyze the value of air quality by relating housing prices to features of dwellings and to the level of total suspended particulates, TSP, in various cities and neighborhoods. And the pattern in the U.S., I think in most places, is that the winds flow from west to east, and what you observe is that generally the west side of cities have nicer neighborhoods, more expensive houses than the eastern sides of cities. But the classical finding is that not very much property value was lost. But a paper by Shea and Greenstone in 2005 does a good job econometrically of doing this calculation, and they determined that a 1 gram per cubic meter decrease in TSP results in a 0.2 to 0.35% increase in property values. That turns out to be many billions of dollars per year in the U.S. from benefit from improvement in vehicle emission standards through the 1970s and 80s. The second method, the so-called travel cost method, is based on the following idea that sometimes you have complementary goods to an environmental condition, and by looking at the demand for the complementary good, you can determine the impact of the environmental condition. In this case, the example is the price of recreational fishing, and in this case, which is the money and time cost of traveling to a site to go fishing, and consumer reluctance to travel to an environmentally injured site reflects the value the consumer places on the energy. So if travel behavior maximizes utility, then you can estimate what's called a discrete choice model, and then use that from that model, determine demand as a function of the equivalent price. An application, trout fishing in Montana, I mentioned before, is a study by Kenneth Train for the Clark Fork River Basin in Montana. And I'll skip the technical details, and here are the results. The willingness to pay for 330 more fish per kilometer of stream are $1.40 on average, with a substantial variation in that over the population. The median value is 0.62 cents. So this model gives a basis for determining whether the benefit exceeds the cost. It also suggests something that's fairly important, and that is that the distribution of willingness to pay it has a distribution that's highly skewed, so that the mean is substantially higher than the median. If you ask median voters whether they would approve the cleanup, that median value is only 62 cents, but if the mean is much higher. Now, there are some limitations to these methods. First of all, they don't account for everything. They're usually quite market specific. More critically, they can detect only welfare effects that leave a clear trace in market behavior. So it's possible for a person to be less happy because of some environmental conditions, such as the threat of climate change or loss of a species, but these worries might not have any impact on their market good demands, in which case the methods I've just described are not helpful. So to value these environmental goods, economists have to elicit behavior by making a market, in a sense, making an experimental market. And this approach is called the stated preference method. And these methods work very well when goods actually trade. They may or may not work when the markets are hypothetical. There is a widely used technique in environmental economics called contingent valuation, which is primarily hypothetical and is controversial because it is, and I'll explain why. Here's an example of the use of the contingent valuation method. The question is, what value would your household place on saving about 50,000 seabirds each year from offshore oil spills? There's some background which explains the nature of the population and the impact of the spills. And then people are asked, are you willing to pay, let's say, $25 a year? That may change experimentally. And they may be followed up with a question as to how much would you, in fact, be willing to pay. Now, there's some issues with the use of this technique. The first ones are economic issues, are comments. One, this technique itself is a part of a special case of what's called conjoint analysis, originally developed for market research. It can be used to elicit beliefs and perceptions as well as preferences. It's actually quite successful in marketing applications with pretty well-defined consumer goods. In environmental applications, it often gives the subject a hypothetical choice that may not have the same incentives as a real market choice problem, and consequently may not elicit the same behavior from a rational economic consumer. Beyond the economic issues, there are some very substantial psychological issues. Experimental evidence is that decision makers are more sensitive to context and less unremittingly optimizing than rationality requires. Cognitive anomalies result. For example, precautionary behavior rules, social interaction, and market discipline limit cognitive anomalies in familiar, repetitive, real markets. And if you apply the contingent valuation method to familiar goods, they will often mimic market behavior reasonably well. However, the cognitive anomalies become more visible in unfamiliar experimental non-market settings, such as environmental valuations, and they can be easily exploited to manipulate the results, which is a scientific problem. That is, one of the reasons this area is controversial is that there is no good scientific standard or yardstick to hold work to, and as a result, the studies are often not easily replicated or not really accepted. Now, what are these cognitive anomalies that cause so many problems? First, I'm going to talk about each one briefly. One is called the endowment effect and or the hedonic treadmill. And the effect of it is that willingness to accept is much larger than willingness to pay. If you think back to Dupuy and the calculations that I described there, they imply that willingness to pay and willingness to accept are either the same or at least close together. And we see psychologically that they are in fact very different. There are also effects of aversion to ambiguity, aversion to losses as opposed to gains, and finally there are what are called context and anchoring effects. I'll try to say a little bit about each. Quickly, on the endowment effect, I'm going to describe an experiment which I did in a classroom in Berkeley. I was a classroom with 345 students, so half the students received a slip of paper entitling them to a pencil with the name of the course on it. The other half received a slip in which they did not get this. And then a market was opened in which they could, if they had received rights to a pencil, they could sell it and put it down a bid. If they didn't receive a pencil, they could write down a bid to buy a pencil. What you would expect is that the distribution of values in the class should be random, and the assignment of these chits for pencils was random. So about half the pencils went to people that were in the bottom half of the value distribution, and those should trade. So about half these 172 pencils, or about 86 pencils, should trade. Here's what happens. What happens is that 32 pencils, not 86, trade. Willingness to pay is 10 cents, willingness to accept is $1, a 10-to-1 difference. These results suggests that there's something that goes on with the psychology of consumers, which makes them either very, very skeptical of trading, period, or if you have something, you instantly give it a great value, and so you attach a great value to being endowed with something. Well, these kinds of effects seem to be extremely strong in environmental evaluations, and are part of the explanation for why in environmental work, willingness to pay and willingness to accept are often very, very far apart. An explanation, a psychological explanation for some of this is that people are on what's called a hedonic treadmill. That's to say, you're very sensitive to gains or losses from your status quo, but you have the distinction between a good status quo and a bad status quo tends to dwindle away. Giving people a lot more money, they're a little happier. They're happier to get it. Once they're settled down at a higher income, they're maybe a little bit happier, but not substantially happier than if they didn't have the money to begin with. So that's the hedonic treadmill. And as I say, these seem to be powerful influences on contingent valuation studies, but they also potentially are present in other studies as well. And there is a lesson there, which is that one needs to be concerned with these psychological effects in any evaluation of an environmental project. Another fairly strong effect is what's called ambiguity aversion, and here I'm not going to ask you to show of hands, but you get to choose either bowl A or a bowl B and then draw a ball from it. If the ball is black, you win a prize. Bowl A, there are 5 white and 5 black balls, and bowl B, you have no idea what the mix of balls is in bowl B. So which would you prefer, bowl A or bowl B? Well, if you do the math, bowl A is essentially has the minimum information. There's no way you could do worse than bowl A. Nevertheless, 80% of people prefer bowl A to bowl B. That's to say, people are adverse to a situation where they cannot see clearly what the odds are, what the probability of winning is. Again, that has some important implications, I think, for environmental evaluation and in general for the public valuing of environmental risk and projects, which is if something is ambiguous, and a lot of environmental problems are, there's a tendency, first of all, to avoid thinking about them, avoid doing anything about them, and if possible, going and solving some problem which is better defined rather than the true ambiguous problem. Other psychological effects. People have difficulty recognizing and processing randomness. They attribute observed patterns to hidden causes. That is to say, they think there's a hidden cause behind whatever pattern they see. They really can't accept that it's truly random. They show beliefs and feedbacks from their behavior to stochastic events, and they show overconfidence in their beliefs. This is a problem for the general population. Unfortunately, it's also a problem for scientists. Scientists often are unwilling to accept the risk in their own beliefs. These perceptual anomalies influence consumer evaluation of risky and ambiguous environmental outcomes and interventions, and I would say as a general matter, it discourages us from taking precautionary action against highly ambiguous and risky outcomes. Finally, context and anchoring. People are sensitive to the framing of evaluation questions. They show strong reference point effects, which depend on what you define as where they're starting from and where they have the opportunity to go. And if they have an unfamiliar evaluation task, they're often sensitive to numerical cues contained in the question. For example, if you're asked, are you willing to pay $24 to do something, it'll prompt a response that's not far from $25. So the responses are said to be anchored to those cues. An example is an experiment that was done by myself and Danny Kahneman, a couple other authors. We gave subjects a question on saving seagulls, the one that you saw before, and questions about some other factual questions about the height of the tallest redwood and so forth. And we did this with two different control group and a treatment group. We used the control group to set levels and then asked the treatments group for whether they would pay a certain amount, 50, 25, 50, 75, 90, or percentile values. And the differences in these two groups show effective response. Here's data for the seagull question. What are you willing to pay to save 50,000 seagulls a year? This is a log scale. You see very large differences between the treatment group and the control group. That is to say, treatment group are people that are prompted with numerical prompts. And the finding is that they tend to give responses that are around those numerical prompts. And so by putting in a very large prompt, you can get a very large implied value. So the conclusions of all this: all three of these methods, hedonic price method, travel cost method, and contingent valuation method, are useful inputs to the task of estimating consumer values for environmental prospects. However, all these methods should be employed cautiously and with a critical eye to the question of whether they measure what is needed for policy analysis and whether they deliver reliable results. Oops. The contingent valuation method is particularly vulnerable to manipulation of results by exploiting cognitive anomalies. These anomalies are present in all these methods, but in the ones that depend on market data, there's less opportunity to manipulate the results. So for CVM, extra care is needed to get results that are scientifically reliable and reproducible. And I would say that overall, the behavioral findings suggest that at minimum, in using any economic method to value environmental prospects, be aware of how phenomena such as endowment effects, ambiguity aversion, and other cognitive anomalies may influence results, and where possible, test for and design experiments that control for these effects. Thank you.